Everyone, we are Team 2. My name is Phan. Here's my fellow, Eduardo Vargas and Gonzalez. Today we are presenting a project in robot modeling class. We are assigned to design a project. To design a robot in several assembly. The project is broken down in two parts. The first part is a survey, and the second part is a design of robotic arms. In the first part, firstly we ask ourselves why we have to use robots in cell phone industry. Secondly, we look at the current designs as well as the technology that available nowadays allow us to design proper robots. We will play a short video to get you guys have a sense of how robots help us in this particular industry. Finally, we will look at the future design of robots to improve the performance as well as the great impact on the environment. On the second part, we're going to do our particular I will pass out my part to Dan.
Thank you, Long. As Long mentioned, one of the important things to consider is why robots are used in cell phone assemblies. These are the three main reasons: efficiency, cost, and quality. Before I get into this, I want to let you guys know that robots and humans are both used in cell phone assembly lines. But the first reason that robots are used is for efficiency. Robots are capable of performing the same task over and over and over again and get the same result. As with humans, they can perform the same task over and over, but the result may be different. Cost is another important thing. Robots, they can be expensive at first. Their initial cost will be great, but they, like humans, they don't need to be paid. They don't have wages, so overall, over the lifetime, they actually become very cheap. They also keep quality pretty high. Like I said before, they are capable of doing the same task over and over and keep up the quality, and a human really can't do that. So robots are actually a great help for manufacturers because they can keep the cost down, making their the products more affordable. The next slide will show you the manufacturers nowadays. These are current designs. The two major manufacturers are KUKA and FANUC. These manufacturers specialize in robot arms. The robots are not only found in cell phone assembly, but they're also found in car assemblies or airplane assemblies. Now we'll pass it off to Daniel Gonzalez, who will show you a little video and give you a little more information. Thank you.
Thank you, Eduardo. The following video will present how robots are used in cell phone assembly. As you could see in the video, we can see the robots are very efficient and reliable to produce a specific task. They can repeat it over and over, while keeping the quality and the standards of the production going. This is how currently manufacturers utilize to create cell phones. And in the future, we can see complete automation, meaning no human interaction will be involved in the production of the cell phones. This will be done by introducing 100% robots in the assembly, as well as flexible design. Flexible design means a factory can convert very easy and very versatile from one design to another design of the robots, and it could produce multiple prototypes at the same time. Now for our project analysis, we have our colleague here, Mr. Phan. He will present the first part of our analysis project. Thank you.
Thank you, Daniel. In our realistic model of robots, we are supposed to solve the problem of inverse position design, meaning that we are given to predefined positions. We will design robot arms, which is 3 degrees of freedom, robot choice, that picks up the cell phone part from one position to another desired position. We also make sure that there are no single position that will lock up the system. In order to do that, we have to make sure the Jacobian has to be a square matrix, and its determinant cannot be 0. Once we solve those equations properly, we will obtain a desired robot. Now I pass off to Eduardo.
Thank you, Long. When we began this project, we had multiple designs and ideas. We wanted to use a prismatic and a revolute joint to get a complete scope of the robotics knowledge we've gained. But after surveying the cell phone assembly lines, we came across a very familiar type of robot, and this is a 3 degree of freedom robot with 3 links. So hence, that's what we decided to use. For our links, our first link length is 45 centimeters, our second link length is 35 centimeters, and our last link length is 20 centimeters. And like as Long said, we had to state 2 starting positions. And from these 2 starting positions, we had to come up with a trajectory for the robot to perform its 2 main tasks. Our first position, we defined it as 0.4530, and our final position was labeled as 2520. And between these 2 points, the robot was supposed to have a smooth trajectory between these 2 points and complete its main tasks. Now we'll pass it over to my colleague Daniel, who will explain the rest of the project.
Thank you, Eduardo. For our project, we have used inverse position analysis for a 3 degree of freedom robot, as Eduardo mentioned. First, we have 2 graphs here that represent the displacement in the x direction and the y direction of the n effector. All the lines except the blue one show the specific angle at a specific time for all the joints and links. The blue line represents the path that the end effector took for the displacement. This path was specified by us, and finally we have an animation that will show the robot with the sign. We have the 3 links, the 3 joints, and finally 90 degrees where the robot will finally place the part I took at the beginning. This finally concludes our presentation, and thank you very much.